Experts say that robotics can drastically change various industries, and some forecasts show that the robotics market could reach $283 billion by 2032. The data has triggered discussions about a new economic era where technology will eventually replace human labor in the coming decades. In this video, let's explore how robotics innovations can reshape our economic landscape, along with the potential opportunities and challenges. Contrary to what most people believe, the use of robotics in industry has been growing steadily. In 2022, the volume of industrial robotic installations hit a new record of 3.9 million. According to the International Federation of Robotics, IFR, the leading countries in automation, measured by robot density per 10,000 employees, are South Korea, Singapore, Germany, Japan, and China. The speed of robotics adoption in factories around the world is impressive. The new global average robot density hit an all-time high of 150 robots per 10,000 employees in 2022, which is nearly 3 times higher than 2013. It seems that robotics are already well integrated into our economy, but what will happen to our economy if this trend continues a fast upward trajectory? First, let's start with the basics. The factors of production: capital, labor, land, and entrepreneurship. Capital includes machinery, buildings, vehicles, and tools used in production, encompassing robots and robotics technology as investments that enhance production capabilities. Labor refers to the human effort in production, including physical and intellectual services workers provide. Land pertains to natural resources such as minerals, water, and arable land. Entrepreneurship combines these factors to create goods and services, driven by risk-taking and innovation. How do capital and labor influence output growth? Based on data from the U.S. Bureau of Labor Statistics, from 2012 to 2022, capital contribution to output growth has been stable at around 1 percentage point on average. Labor's contribution has also averaged around 1%, though it fell sharply in 2020 due to the COVID-19 pandemic, which caused job losses, but it recovered strongly in 2021 and 2022. In the short term, integrating robotics into production processes resulted in immediate productivity and efficiency improvements. This technology represents an investment that can lead to capital deepening, where the amount of financial assets per worker increases, enhancing productivity by performing tasks faster, more accurately, and more consistently than human workers. For example, Amazon, the world's second-largest private employer, had 1.5 million employees in 2022, a decrease from 1.6 million in 2021. Meanwhile, the number of robots at the company surged from 200,000 in 2019 to 750,000 in 2023, highlighting how robotics can amplify capital investments and replace manual labor. This shift underscores the importance of workforce retraining and education to prepare workers for new roles. Using robots extensively can raise labor productivity and boost economic growth. A study by economists George Grates and Guy Michaels, published by London's Center for Economic Research, found that industrial robots significantly drive productivity and GDP growth. Analyzing data from the International Federation of Robotics across 14 industries in 17 countries from 1993 to 2007, they concluded that robotics in manufacturing raised annual labor productivity growth by 0.36 percentage points and GDP by 0.37 percentage points, accounting for 10% of total GDP growth and 16% of labor productivity growth during the study period, even though robotics comprised just 2.25% of the industry's total assets. But we might see the law of diminishing marginal productivity applied here. Also known as the law of diminishing marginal returns, it states that as more units of a variable input, like robots, are added to fixed inputs, such as machinery or factory space, the additional output produced by each new unit eventually decreases. This means that significant benefits from the initial integration of robots can decrease over time as more robots are added. As industries become saturated with robots, the impact on productivity and economic growth could plateau, requiring further innovations and investments in complementary technologies and human capital to sustain growth. Nonetheless, significant investment in robots and technology may not always be directly proportional to productivity gains that many of us would expect. This is known as the productivity paradox and was observed by MIT economics professor Robert Solow, who won the Nobel Prize in Economics in 1987. It questions why technological advancements don't always result in expected productivity improvements, emphasizing the complexity of integrating new technologies into existing economic structures and the need for continuous adaptation and innovation. As demand for robotics grows and production volume rises, the cost of robotics per unit will drop due to economies of scale. Consequently, the human labor required for routine manual tasks will decline as robots become more capable and cost-effective. This widespread automation can significantly reduce labor contribution to production output. In the long term, labor's role could be almost entirely replaced by robotics and capital contributions, leading to very high unemployment and the emergence of a post-labor economy where human labor is no longer a significant production component. Imagine industries where the workforce consists primarily, if not entirely, of robots. But what could be the possible policy responses to these profound changes? French economist Thomas Piketty, in Capital in the 21st Century, argues that historically, returns on capital have outpaced economic growth, leading to increased inequality. As a form of capital, robotics could further concentrate wealth among a few technology owners, magnifying income inequality. Piketty suggests progressive taxation and wealth redistribution as solutions. Additionally, policies like taxing automated businesses or implementing a universal basic income, known as UBI, a government program designed to provide a set amount of income to all adult citizens regularly, could help ensure that benefits of robotics are shared more broadly. Another approach could involve government ownership or stakes in highly automated companies. For example, the Norwegian state owns about 70% of the share capital of Equinor ASA, ensuring that profits from Norway's natural resources benefit Norwegian society. Similar structures could be applied to highly automated industries to distribute benefits more equitably. While this model might not be applicable in all countries, especially those without a history of state-owned enterprises, it could be sustainable for some European nations like Norway or Sweden, which have a tradition of strong state involvement in the economy. Is it realistic, though, to think that robots can replace all human activities in the economy? Many experts suggest that robots might struggle with or can never replace all tasks. For instance, take entrepreneurship, which, as we mentioned earlier, is also a factor of production. Some experts argue that robots don't, and most likely wouldn't, have the creativity and ingenuity of entrepreneurs like Bill Gates or Elon Musk. Beyond entrepreneurship, there are other areas where humans excel and robots might struggle, such as the creative arts. Humans possess the unique ability to create original works of art, music, and literature that involve deep creativity and emotional expression. Innovation, especially thinking outside the box and coming up with groundbreaking ideas, is also a distinctly human endeavor that robots might find difficult to imitate fully. Emotional intelligence is another important area where people outshine robots. Empathy, the ability to understand and share the feelings of others, is a complex human trait. Professions that require high emotional intelligence, such as teaching, counseling, and social work, rely heavily on our capacity for deep emotional connections and support. Complex tasks, such as making ethical judgments and decisions involving moral considerations, require a personal touch. Leadership, which involves motivating and understanding people and making strategic decisions in dynamic environments, is another area where humans excel. The same can be said for social interaction, as well as negotiation and nuanced customer service interactions, requiring reading body language, understanding implicit cues, and providing personalized responses. These social skills are challenging for robots to master. When it comes to hand-on skills, we should consider skilled trades like craftsmanship, gourmet cooking, and intricate manual work. These involve a level of dexterity, creativity, and adaptability that robots may not easily be able to copy and do effectively. Caring professions are another key area, with roles such as nursing, caregiving, and teaching that involve not only technical skills, but also emotional support, understanding of patient or student needs, and creating nurturing environments. And let's not forget cultural and social understanding. For instance, diplomacy requires understanding and appreciating cultural nuances, traditions, and social dynamics, which necessitate a level of social awareness and sensitivity that are inherently human. These areas highlight the unique strengths of humans and the limitations of robots, even as technology continues to advance. While robots and AI can complement and enhance the capabilities of people, the irreplaceable qualities of creativity, empathy, adaptability, and cultural understanding ensure that there will always be a significant role for humans in the economy. If we're talking long-term, the widespread of adoption of robotics and automation will have significant macroeconomic consequences. It's understandable if you think these ideas are kind of gloomy because of the potential increase in unemployment. The great news is there are also opportunities and positive aspects that robotics could offer to the economy. In economics, this is referred to as positive externalities, good effects that are not included in the cost or market transactions. These beneficial effects include enhanced workplace safety by taking over hazardous tasks and environments. For instance, robots can handle toxic chemicals, work in extreme temperatures, and perform repetitive heavy lifting. This means that the risk of injury to human workers is greatly reduced, if not eliminated. Additionally, robots, unlike humans, can operate 24/7 without fatigue, leading to increased productivity and efficiency. Their non-stop operation could allow businesses to meet higher demands and optimize their production schedules. Robots can also perform tasks with higher precision and consistency, ensuring better quality products. This level of accuracy is particularly beneficial in industries like electronics and pharmaceuticals, where precision is crucial. Although the initial investment in robotics can be high, the long-term cost savings for enhanced productivity, reduced labor cost, and fewer workplace accidents can be equally substantial. Businesses can reinvest these savings into other advances and improvements. Furthermore, the growth of robotics can encourage innovation and the creation of new industries and job opportunities. For example, skilled workers are needed to develop, program, and maintain robots, driving the demand for human expertise in these areas. Robotics can also contribute to environmental sustainability. Precision agriculture robots, for instance, can optimize the use of water and fertilizers to reduce environmental impact. On the other hand, robots can efficiently sort materials to boost recycling rates and reduce waste. In the healthcare sector, robots can assist with surgeries, rehabilitation, and patient care for more reliable outcomes and efficiency. Surgical robots enable minimally invasive procedures, reducing recovery times and improving patient experiences. To summarize, robotics is a major technological and economic force that will shape our world in the coming years. It presents significant opportunities for innovation and efficiency and challenges the need for careful management and understanding. The integration of robotics into various sectors is set to profoundly impact both macro and microeconomic levels, driving productivity gains, GDP growth, and new market opportunities. However, our perspective is that the complete elimination of humans from production activities and the advent of a post-labor economy will not be as swift or straightforward as many might anticipate. Thoughtful policy and investment will be crucial in managing these transitions, addressing risks like job displacement and income inequality, and ensuring we harness the full potential of robotics for a better future. Thanks for watching. Please like and subscribe for more detailed videos on economics.